CompTIA A+, 220, 1101, and 1102. Printers. Printers. All types and specifications. Laser printer. The following are the steps in the printing process of laser printers. Processing stage. Laser printers produce output as a series of dots. The OS driver encodes the page in a page description language and sends it to the print device in the processing stage. The printer's formatter board processes the data to create a bitmap or raster of the page and stores it in the printer's RAM. Charging stage. In the charging stage, the imaging drum is conditioned by the primary charge roller, PCR. The PCR is a metal drum roller with a rubber coating powered by a high voltage power supply assembly. The PCR applies a uniform 600 volt electrical charge across the drum's surface. Exposing stage. The surface coating of the photosensitive imaging drum loses its charge when exposed to light. In the exposing stage, as the laser receives the image information, it fires a short pulse of light for each dot in the eraser to neutralize the charge that was applied by the PCR. The pulsing light beam is reflected by a polygonal mirror through a system of lenses onto the rotating photosensitive drum. The drum ends up with a series of razor lines with charge/no charge dots that represent an electrostatic latent image of the image to be printed. Developing stage. Laser toner is composed of a fine compound of dye stuff and either wax or plastic particles. The toner is fed evenly onto a magnetized developer roller from a hopper. The developer roller is located very close to the photosensitive drum. The toner carries the same negative charge polarity as the drum, which means that, under normal circumstances, there would be no interaction between the two parts. However, once areas of charge have been selectively removed from the photosensitive drum by the laser, the toner is attracted to them and sticks to those parts of its surface. The drum now is coated with toner and the image of the document rotates until it reaches the paper. Transferring stage. The transferring stage moves the toner from the drum onto the print media. The paper transport mechanism includes components such as gears, pads, and rollers that move the paper through the printer. Pickup components lift a single sheet of paper from the selected input tray and feed it into the printer. To do this, a pickup roller turns once against the paper stack, pushing the paper into a feed and separation roller assembly. This assembly is designed to allow only one sheet to pass through. When the paper reaches the registration roller, a signal tells the printer to start the image development process. When the drum is ready, the paper is fed between the imaging drum and the high voltage transfer roller. The transfer roller applies a positive charge to the underside of the paper. This causes the toner on the drum to be attracted to the paper. As the paper leaves the transfer assembly, a static eliminator strip, or DTAC corona, removes any remaining charge from the paper. This is done to avoid the paper sticking to the drum or circling as it enters the fuser unit. Fusing stage. From the transfer assembly, the paper passes into the fuser assembly. The fuser unit squeezes the paper between a hot roller and a pressure roller so that the toner is melted onto the surface of the paper. The hot roller is a metal tube containing a heat lamp. The pressure roller is typically silicone rubber. The heat roller has a Teflon coating to prevent toner from sticking to it. Cleaning stage. To complete the printing cycle, the photosensitive drum is cleaned to remove any remaining toner particles using a cleaning blade, roller, or brush resting on the surface of the drum. Any residual electrical charge is removed either a discharge or erase lamp or PCR. Laser printer. Printer components explained. Toner cartridge. A toner cartridge contains colored or carbon oxide iron powder toner that is positively charged and then melted onto paper. Toner cartridges are a consumable item that needs to be replaced in a laser printer. Once the cartridge is empty and is available in 4 different colors: black, cyan, magenta, cyan, and yellow. Drum unit. A drum unit is a metal cylinder that has a special coating, green color, that can receive a static positive and negative electrical charge from the laser within a laser printer. The drum can be seen in the printer as a green cylinder and can sometimes be built into the toner cartridge rather than a standalone unit. The drum receives its initial charge from the corona wire, which is heated during the printer warm-up process. Laser. The laser part of the printer transmits light from the diode across a series of mirrors. They reflect the laser onto the drum unit to imprint the shape of the intended print. Transfer belt. The transfer belt moves the paper through your printer and passes it across the drum so that the toner can be transferred. Some smaller printers transfer belt. The transfer belt moves the paper through your printer and passes it across the drum so that the toner can be transferred. Some smaller printers do not have a transfer belt, but instead have rollers that act in the same way as a belt. Fuser unit. The fuser unit is a heated roller that melts the toner particles onto the page as it passes through. This seals the toner to the page so it is no longer in powder form, and makes sure that the toner does not smudge, fall off the paper when it comes out the printer. Laser printer. Problems associated with laser printers and probable causes. Speckled pages. The cause for this may be a failure to clean the drum after printing, or the drum might have developed scratches. Blank pages. The causes for white pages may be the toner would have dried out, replace the toner. The transfer corona that is responsible for transferring the toner to the drum might have failed. The high voltage power supply, HVPS, failure will also result in white pages. Ghosted images. Ghosting occurs when previously printed pages are printed again, though much lighter than the presented image. The most likely cause is that the erasure lamp might not be working properly, thus leaving some charges representing the earlier image left on the photosensitive drum before the new image is written. Also, check the cleaning blade, which is responsible for scraping the residual toner. Smudged images. If the fusing fails, the toner will not bond with the paper. Check the halogen lamp, responsible for heating. Typically, a laser printer maintenance kit consists of fuser fixing assembly, pickup roller, transfer roller, gloves, and instruction manual. Inkjet printer. Inkjet printer imaging process. Inkjets work by firing microscopic droplets of ink at the paper. The process creates a high-quality image, especially when specifically treated paper is used, but they can be prone to smearing and fading. There are 2 types of inkjet print heads. Epson printers use a charge or piezoelectric method. HP, Canon, and Lexmark use a thermal method. Each of these 4 vendors have licensed its inkjet technology to several other vendors to produce rebranded versions of its printers. With thermal method, the ink at each nozzle is the printhead is heated, creating a bubble. When the bubble bursts, it sprays ink through the nozzle and draws more ink from the reservoir. In its general, thermal inkjet printheads are cheaper and simpler to produce, but the heating elements have a relatively short life. Most thermal printers use a combined printhead and ink reservoir. When the ink runs out, the printhead is also replaced. In the Epson design, the nozzle contains piezoelectric element, which changes shape when a voltage is applied. This acts like a small pump, pushing ink through the nozzle and drawing ink from the reservoir. Carriage system. Inkjet printers build up the image line by line. The printhead is moved back and forth over the paper by a carriage system. On some types of printers, ink is applied when the printhead moves only in one direction. Bidirectional models apply ink on both outward and return passes over the page. The carriage system uses a stepper motor, pulley, and belt to move the printhead, and a guide shaft to keep the printhead stable. Sensors to detect the position of the printhead as well. A flat ribbon data cable connects the printhead to the printer's circuit board. When a line has been completed, another stepper motor advances the page a little bit, and the next line or row is printed. There may also be a lever used to set the platen gap, or the printer may adjust it automatically depending on the driver settings. The platen gap is the distance between the printhead and the paper. Having an adjustable platen gap allows the printer to use thicker media. Paper handling and duplex assembly. Most inkjet printers only support one paper path with single input and output trays. Though some have automatic duplexers and some may have accessory trays, printers are generally split between models that load from the top and output from the bottom, and those that have both input and output bins at the bottom and turn the paper up and over path. The paper pickup mechanism is similar to that of a laser printer. A load roller turns against the paper stack to move the top sheet, while a separator roller prevents the more than one sheet from entering. When the paper is sufficiently advanced, it is detected by a sensor. The stepper motor controlling the paper feed mechanism advances the paper as the printhead completes each pass until the print is complete. The eject rollers then deliver the paper to the duplexing assembly, or the output bin. Some inkjets with a curved paper path may have a straight-through rear panel for bulkier media. Inkjets tend to have smaller paper trays than laser printers, and therefore can need restocking with paper more often. Most inkjets can use regular copier/laser printer paper, but better results can be obtained by using less absorbent, premium grade of paper stock, specifically designed for inkjet use. Often, this type of paper is designed to be printed on one side only. Make sure the paper is correctly oriented when loading the printer. Replacing inkjet cartridges. Inkjet printheads are often considered consumable items. Often this is unavoidable because the printhead is built into the ink cartridge, as is the case with most, but not all, thermal print inkheads. Epson piezoelectric printheads are non-removable and designed to last as long as the rest of the printer components. The cartridge reservoir has sensors to detect the level of ink remaining. A color printer needs at least 4 reservoirs for each of the CMYK inks. These reservoirs may come in a single cartridge, or there may be separate cartridges for black and or colored ink, or each ink may come in its own cartridge. Some inkjet use light cyan and magenta inks to support a wider color gamut. When the inkjet's driver software determines that a cartridge is empty, it will prompt you to replace it. Check the printer's instruction manual for the correct procedure. Other inkjet maintenance operations. 2 other maintenance operations may be required periodically. Printhead alignment. If output is skewed, use the printhead alignment function from the printer's property sheet to calibrate the printer. This is typically done automatically when you replace the ink cartridges. Printhead cleaning. A blocked or dirty nozzle will show up on output as a missing line. Use the printer's cleaning cycle to try to fix the problem. If it does not work, there are various inkjet cleaning products on the market. Thermal printer. Direct thermal printer imaging process. Most direct thermal print devices require a special thermal paper that contains chemicals designed to react and change color when it is heated by the heating element within the printer to create images. In the feed assembly, paper is friction fed through the print mechanism by a stepper motor, turning a rubber-coated roller. Roller and labels may fan fold or roll format. Direct thermal printer maintenance tips. When you are replacing the paper roll, you need to obtain the specific size and type for the brand and model of thermal printer you are using. The process is usually quite simple. Just open the printer case, insert the roll, keep the shiny, heat-sensitive print side facing outward, then ensure that the end of the paper is held in place by the printhead when closing the case again. Each receipt is separated by ripping the paper across serrated teeth. This can lead to a buildup of paper dust in the printer. It can also lead to bits of paper debris becoming lodged in the mechanism. If a clean slice is not made and bits of leftover paper fall into the printer, use a vacuum or soft brush to remove any paper debris. Label printers can end up with sticky residue inside the label printer. If labels are not glued correctly, they can separate from the backing while being fed through the printer. You will need to ensure users know how to properly load labels and how to clean up labels if they get stuck inside the printer. Use a swab appropriate cleaning fluid such as isoperox alcohol IPA to clean the printhead or any sticky residue, inhibiting the feed mechanism. Alternatively, you can purchase cleaning cards to feed through the printer cleaning head and clean the head safely. Impact printer. An impact printer strikes an inked ribbon against paper to leave marks. One common type is the dot matrix printer, which uses a column of pins in a printhead to strike the ribbon. Desktop dot matrix devices are no longer very widely deployed for document printing, but they are still used for specialist functions such as printing invoices or payslips on continuous tractor-fed paper. Impact printer paper. Impact printers can be used with either plain, carbon, or tractor-fed paper. Plain paper is held firmly against the moving roller, the platen, and pulled through the mechanism by friction as the platen rotates. A cut steel feeder may be added to some printers to automate the process of providing the next page. Carbon paper, or impact paper, is used to make multiple copies of a documentation in the same pass, hence carbon copy, or CC. A sheet of carbon paper is inserted between each sheet of plain paper, and when the print head strikes, the same mark is made on each sheet. Tractor-fed paper is fitted with removable, perforated side strips. The holes in these strips are secured over studded rollers at each end of the platen. This type of paper is more suitable for multi-part stationery, as there is less chance of skewing or slippage since the end rollers fix the movement of the paper. When you are loading a tractor-fed impact printer with paper, ensure that the holes in the paper are engaged with the sprockets and that the paper can enter the printer cleanly. Ensure that the lever is in the correct position for friction-fed or tractor feed as appropriate for the media being used. Impact printer components. An impact printer will also have some form of replaceable ribbon. Older style printers used to have a two-spool ribbon. However, most units now have a carriage device that slots over or around the carriage of the printhead. These integrated ribbons simplify the design of the printer because they can be made as a complete loop moving in only one direction. The two-spool design requires a sensor and a reversing mechanism to change the direction of the ribbon when it reaches its end. When the ribbon on an impact printer fails to produce sufficient good print quality, the ribbon holder and contents are normally replaced as an integrated component. Some printers can use a reusable cartridge, CAB. Follow the manufacturer's instructions to replace the printhead. Take care, as the printhead may become very hot during use. 3D printer. 3D print process builds a solid object from successive layers of material. The material is typically some sort of plastic, but there are some printer types that work with rubber, carbon fiber, or metal alloys too. 3D printing has a very different use to printing paper. It is mostly and widely used in manufacturing, especially to create waterproof concepts, working models from designs. The range of other applications is growing. However, for example, 3D printing can be used in healthcare, dentistry, and prosthetics, the clothing industry, and to make product samples and other marketing materials. The 3D printer imaging process. The 3D printer imaging process begins with either a scan of an existing object or by creating a design using a 3D modeling software. From either of these methods, you end up with a 3D model created in a software and saved to a 3D model format. The model is rendered into discrete horizontal layers or slices. The slicing software might be contained in the 3D modeling software or within the 3D printer. The result is a print job, specifically how each layer in the finished object is to be disposed. The sliced model is then fed to the 3D printer over a USB or Wi-Fi connection, or by inserting an SD card containing the same file into the printer. The printer then melts a filament and extrudes it onto its surface, creating layer upon layer based on the slices. The extruder is moved as needed on X, Y, Z axes to create the build. 3D print components. There are several types of 3D printers. Fused filament fabrication, FFF, also known as fused deposition modeling, FDM, lays down layers of filament at a high temperature. As layers are extruded, adjacent layers are allowed to cool and bond together before additional layers are added to the object. The main components in an FDM 3D printer are print bed/build plate, a flat glass plate onto which the material is extruded. The bed is usually heated to prevent the material from warping. The bed must be leveled for each print job. This is usually automated, but cheaper print models require manual calibration. It is very important that the printer frame be strong and rigid, enough to keep the bed as stable as possible. Any vibration will result in poor quality printing. Bed/build surface. A sheet placed onto the base plate to hold the object in position while printing, but also allow its removal on completion. The bed surface material may need to be matched to the filament material for best results. Extruder. The equivalent of a print head in an inkjet, a motor in the extruder draws filament from the cold end through the nozzle or hot end, where it is melted and squirted onto the object. Different size nozzles can be fitted onto the extruder. Gears, motors, motor control. This enables precise positioning of the extruder. Fans. Cools the melted plastic where necessary to shape the object correctly. The printer must be installed in a suitable environment. A stable, vibration-free floor and dust-free, humidity-controlled surroundings will ensure best results. Filament. The ink for a 3D printer is supplied as a spool of filament. Filament is provided in a diameter of either 1.75 millimeters or 3 millimeters. There are various filament materials. The two most popular plastics are polylactic acid, PLA, and aeroclamy, but ABS. Most printers can use a range of filament types, but it is best to check compatibility if it is specific, exotic, is required for a product. Each material operates at different extruders and print bed temperatures. To change filament, the extruder must be heated to the appropriate temperature. Pull as much of the old filament out as possible. Take care not to burn yourself. Then, push the new filament through. Do not start printing until the old filament has been pushed out. Filament spools require careful storage once open. They should be kept free from heat and humidity. Resin and other 3D printer types. There are two other common types of 3D printers. These use different materials than filament. Stereolithography, SLA, uses liquid plastic resin or photopolymer to create objects which are cured using ultraviolet lasers. Excess photopolymer is stored in a tank under the print bed. The print bed lowers into the tank as the object is created. A liquid solvent removes uncured polymer after the model is finished. Selective laser sintering, SLS, fuses layers together using pulse lasers. The object is created from a powder and lowered into a tank. As each layer is added, the powder can be